Hi guys, welcome you all to my channel Explore Edu to Teach. So today we'll be learning another important concept in signal and systems, that is the discrete time Fourier transform or the DTFT. Now it's a very important concept in signal systems and we need to understand this concept in detail properly in order to go about this particular concept. So in this particular video, it's going to be a short video in which I'm going to tell you about what is DTFT and we are going to understand some basic properties on DTFT. If you are interested after this video in order to have a particular video on numericals on DTFT, please let me know in the comment section. Also, there will be certain formulas which will be uploaded on my Instagram page also regarding this topic. The links are given down in the description box of my Instagram page, that is Explore Edu to Teach. Please follow me over there as well. You will get all the formula sheets which are necessary to each and every topic which will help you in your examinations. So let's try to understand DTFT. What is DTFT? What are the properties of DTFT? And once you understand this, I'm sure you'll be able to solve problems on it. It's going to be a short video, but if you're really interested in order to have numericals video on DTFT, let me know in the comment section. I'll try to bring about a video on the numericals of DTFT. Okay, so what do you understand by DTFT or discrete time Fourier transform? So as we learned, in case of CTFT, there are videos which are uploaded on my YouTube channel playlist in Signal Systems on CTFT. So please go and watch it out. So over there, as we learned that CTFT basically has x of t. Similarly, DTFT is discrete time will have x of n. Your CTFT is x of omega, your DTFT is x of e raised to j omega. Your CTFT formula was something different. DTFT formula is x of e raised to j omega is equal to summation minus infinity to infinity x of n e raised to minus j omega n. So I hope I am very clear. Your x of e raised to j omega is equal to summation minus infinity to infinity x of n e raised to minus j omega n. Similarly, if DTFT is given to you and you need to find out the discrete signal, you need to apply the inverse DTFT, that is x of n is equal to 1 by 2 pi integration minus pi to pi x of e raised to j omega e raised to j omega n d omega. So that is very important. So you have a signal x of n which is a discrete signal. The x of e raised to j omega is the DTFT, that is a discrete time Fourier transform. So x of e raised to j omega is given as summation minus infinity to infinity x of n e raised to minus j omega n. And if you need to find out the x of n from x of e raised to j omega, the formula says 1 by 2 pi integration minus pi to pi x of e raised to j omega e raised to j omega n d omega. So now we'll try to learn some properties, some handy formulas. This formula sheet is present in the description box of my YouTube video as well as on my Instagram page. So please check it out. So you need to know this some formulas handy which will help you in the numericals. Instead of deriving the formula in the examination, if you know the formulas handy, it's going to be helpful for you to apply them in the numerical straight away in the examination. It will save your time as well. So it says, if there is a signal a of n u of n given, what is going to be the Fourier transform of it? The Fourier transform can be in two ways depending upon the value of magnitude of a. If the value of magnitude of a is smaller than 1, the DTFT is 1 upon 1 minus a into e raised to minus j omega. If the value of mod is greater than 1, it's given as 1 upon 1 minus a into e raised to j omega. So this is one of the most like good numericals which can be formed in the paper. They give you a of n into u of n, and you should know both this condition. If it's a competitive exam, they'll give you both the options to confuse you. So you should know the formula very correctly based on the classification of mod of a being smaller than 1 and mod of a being greater than 1. Okay. The DTFT is basically periodic with time period 2 pi. I hope I'm very clear with this. Next, you have if x of n is x of e raised to j omega, similarly x of n minus n naught will be x of e raised to j omega e raised to minus j omega n naught. I hope I am very clear with this. Similarly, if you have e raised to plus or minus j omega naught n x of n, then the Fourier transform of this will be x of e raised to j omega minus plus omega naught. I hope I am very clear. Similarly, as you learned, we have the formula a raised to n u of n as Fourier transform being as this. Similarly, if you have minus of a raised to n u of minus n minus 1, what is going to be the Fourier transform of it? You can divide it into two parts as mod of a greater than 1 and mod of a smaller than 1. Mod of a greater than 1 is given as 1 upon 1 minus a into e raised to minus j omega, and 1 upon 1 minus a into e raised to j omega for mod a smaller than 1. So be very clear over here. As I told you, there can be a numerical, especially in competitive exam, where they'll give you this particular kind of, like a will be any value, and they'll ask you to find out the Fourier transform of it. So in that case, do not forget to apply this onto numerical with the value of correct value of mod a. I hope I'm very clear. Similarly, you have x of n given as x of e raised to j omega. So the x conjugate of n is given as x conjugate of e raised to j omega. Fine. So next you have x of n given as x of e raised to j omega. Similarly, n into x of n Fourier transform is given as j into d by d omega into x of e raised to j omega. So know all these formulas very well. If you like this particular video and you want that a particular new video should be brought on the application of this formula to numerical, please comment in the comment section. I'll try to bring about a video for the same. If you like this video, it was a very short video. Do not forget to like, share, subscribe to my YouTube channel. Share it to as many people as you can. And also follow me on Instagram for all the updates and for all the formula sheets and all these like short videos which are regularly updated on my Instagram page in regard to all the different concepts. So thank you so much guys. God bless you.